So question 5, first of all, we know that the line AB, the chord AB, divides the circle into two segments, a large segment and a smaller segment, and the areas are in the ratio 3:1. So the first thing that I'm going to do is work out the area of the small segment. So if I shade that in green, it's this green area over here. And I'm going to give the circle a radius of r, as we're not given a numerical value for the radius, and the area of the small segment is equal to the area of the sector OAB subtract the area of the triangle OAB, which leaves us with the green segment. So the area of the sector is a half r squared theta, and the area of triangle OAB is a half AB sine c, or a half r squared sine theta, using our area of a triangle formula. So that's the area of the small segment. Now, the area of the large segment will then be the area of the whole circle, which is pi r squared, take away the area of the small segment. And by the area of the large segment, we mean this area here. It's the easiest way to work it out. Whole circle, take away the green segment area. So that's pi r squared, take away a half r squared theta minus a half r squared sine theta. And this comes to pi r squared minus a half r squared theta plus a half r squared sine theta. Now, what we know is that the ratio of the large segment area to the small segment area is 3:1, which tells us that the large segment area is equal to 3 times the small segment area, looking at the ratio. And we have all of the information we need over here to set up some sort of equation. So the large segment area is pi r squared minus a half r squared theta plus a half r squared sine theta. And this is equal to 3 multiplied by the area of the small segment, which is equal to a half r squared theta minus a half r squared sine theta. Let's simplify. Pi r squared minus a half r squared theta plus a half r squared sine theta equals 3/2 r squared theta minus 3/2 r squared sine theta. Now, there is a common factor of r squared, and we can divide every single term by r squared. And we can then collect some like terms as well. We have this term here and this term here. And we also have this term here and this term here, and these can be collected. So I'll leave pi on the left-hand side here, and the two green terms, the terms that I've underlined in green here, I can collect those on the right-hand side, and that gives me 2 theta. And then I can collect the other terms, which give me minus 2 sine theta. And then if I divide everything through by 2, I get pi over 2 equals theta minus sine theta, which is the answer in the question. So question 6, part 1, we have to work out the perimeter of the shaded segment, which I've shaded in red. So the perimeter of this segment is going to be composed of the arc from, let's say, A to B, plus the chord length from A to B. Now, we know that arc length, when our angle is given in radians, is simply equal to r theta. So the arc length, I'll highlight it in blue so you can see it clearly, hopefully, is equal to r theta. And the chord length, let's work that out. Let's focus on this triangle here, ABO, and I'm going to split it into half like that. And then let's focus on a single green shaded triangle like that. Let's call M the midpoint of AB. There's B and there's O, and then this angle here will be a half of theta, and this distance O to B we know is the radius. So we know that sine of a half theta, or theta over 2, is the opposite, MB or BM over OB, the hypotenuse. So sine theta over 2 is equal to BM divided by R, which tells me that BM is equal to R multiplied by sine theta over 2. But we want the whole chord length, which goes from A all the way to B, and we know that AB is equal to 2 lots of BM, so it's 2 times R sine theta over 2, which gives us an opportunity to write the chord length here as 2R sine theta over 2, and if we simply factorise R out, we get R bracket theta plus 2 sine theta over 2, which is what was required in the question. The second part of the question asks us to work out the area of the shaded segment, and the area of the segment is of course equal to the area of the sector minus the area of the triangle. So the area of the sector OAB minus the area of the triangle OAB. Now the area of the sector is of course a half r squared theta, and the area of the triangle is a half AB sine C, so a half multiplied by r multiplied by r multiplied by the sine of the angle between them, and this time we're working out the area of the whole triangle as 1, so we're using the whole angle theta here, and this, if we factorise out a half r squared, we have theta minus sine theta inside the bracket, which is what is required in the question. So let's take a look at question 9. The area of sector OPA, we can simply use our formula for the area of a sector, a half r squared theta. So a half multiplied by 3 squared multiplied by pi by 4, which simplifies to 9 pi by 8 meters squared. Part 2, we have to work out the area of sector OQB. Now, to work out the area, we need to know the angle, and we can use the fact that the angle is made up of 3 parts, a pi by 4, a pi by 12, and another pi by 12, because the two triangles, OAB and OPQ, are congruent or identical. So this angle here, the angle QOB, is equal to pi by 4 plus pi by 12 plus pi by 12. So that comes to 5 pi by 12 as an angle. So the area of the sector OQB is equal to a half multiplied by 8 squared multiplied by the angle 5 pi by 12, which simplifies down to give us 40 pi over 3 meters squared. Now, for part 3, we have to work out the area of the flower bed, which is the shape PABQ. I'm not going to attempt to draw this, but we can see that this area will come from taking the area of the sector OQB, and then we need to subtract from that the area of the small sector OPA, and then we need to subtract from that the area of the triangle OAB and the triangle OPQ, but these two are the same triangle. So the first thing that I'm going to do is to work out the area of triangle OPQ. And I have a diagram up here actually, which I can make use of. Highlight it in red so you can see it. Now the only thing I need to mark on that triangle is the angle here, which we know is the same as the angle AOB, it's pi by 12. And the area of a triangle is a half multiplied by A, one side, we'll call it 8, multiplied by B, another side, we'll call it 3, multiplied by the sine of the angle in between them, which is sine pi by 12. Okay, remember the formula I'm using, area of triangle is a half AB sine C, which you should know from your trigonometry. So this simplifies to 3 root 6 subtract 3 root 2, giving this an exact third form. So let's put this all together to work out the area of the flower bed. So the area of the sector, first of all, OQB, well that was here, it's 40 pi over 3. Now the area of the sector OPA, that's over here, so we want to subtract 9 pi over 8. And then for this last part, we want to make sure that we subtract 2 of these because both triangles are identical, so we want 3 root 6 minus 3 root 2. So this gives us a final answer for the area as this value over here. Now we may want to actually work that out and give a decimal answer because it's not really the neatest calculation as it is, and this comes to 32.14195, etc. So I could round that to 32.1 meters squared to 3 significant figures.